Welcome to Layers with Larry. I'm Larry. These are my layers. So the frontier formation formed when the seas retreated from the great interior seaway that existed for so long. But then it came back. The Cody Shale is a very thick section, about 2,000 feet thick, just loaded with beautiful, interesting fossils. This video will continue from the last one that you probably just watched about the Nautilus, which, by the way, is a type of creature known as a cephalopod. Cephalopod, that's a strange word. Well, a podiatrist studies your feet, so cephalopod has something to do with feet because the pod's there. And ceph is a old Greek or Latin word that refers to the head. So cephalopod means head foot. Kind of a weird name, but if you think about it, like this model demonstrates here, imagine this is like a living Nautilus that we talked about last time. He's got his eyes as clearly as sort of his head is right here, but look what's right where his head is like his feet, his tentacles. So his head is where his feet are. What's up with that? That's kind of strange. And it's an invertebrate, so he doesn't have a spine or backbone like us. The ones you know that live today are ones like, let's say, octopus, a squid, cuttlefish. You might not have heard of that before, but they're all soft-bodied creatures. They don't have shells on the outside, but their ancestors did. Today we're going to focus mostly on creatures called Ammonites, and these are fascinating creatures. They lived almost as far back as the Nautilus did. They're kind of related, but kind of not. They survived the great extinction at the end of the Permian about 250 million years ago, just like the Nautilus did. But unlike the Nautilus, who exists all the way to today, the Ammonite no longer exists, so we'll have to address that. So why are they called Ammonites? Well, it's an interesting question. In geology, often you hear a lot of terms that end in "ite." And so here's a little bit of vocabulary, geology vocabulary. Anything that ends in "ite," the "ite" part literally means like rock or stone. And an Ammonite ends in that, so it's something stone. Ammon, if you know your Greek or Egyptian history in particular, there's a very famous Greek or Egyptian god, sort of the top god in the Egyptian pantheon, and he's known as Ammon. Ammon was always represented with a ram's horn on his head. Ammonite literally means the stones of Ammon. So they're mostly coiled up like ram's horns, but as we get into them a little bit, we're going to learn that their ancestors started as straight-shelled creatures. They coiled up over time, similar to the Nautilus, and some of them even uncoiled into extremely straight examples, and some were kind of in between. They're known as heteromorphs, another fancy word. That just means like other form, other shape, other than the coil. So we remember basically what our Nautilus looks like. You can see how very similar it is in form to this creature. This is an Ammonite, this is a Nautilus, nautiloid. They look very similar, they lived very similarly, just like the Nautilus. Inside they have these chambers which they could fill with a mixture of liquid or water, fluids, and gas, and control their buoyancy so that they can move in the water. They had a body very similar to a Nautilus. They used that little siphon device to squirt water out so they could move around, and if they wanted to change position, they could do that by adjusting the amount of gas. But there's some important differences. The Nautilus has a very thick shell, and so it's protected from changes in water pressure pretty well because of that, and also protected against predators. Now, if you're fairly slow moving and a big jawed fish comes along, or a creature called a mosasaur, take a look at this picture. Well, they didn't have such thick shells, these Ammonites. They're quite thin-shelled, so you'd think they'd be really easy prey. Well, the way they solved that problem was having a thin shell. They could grow faster, get bigger, but they'd be more vulnerable because of the thin shell. They developed a very complicated structure inside themselves. This is a portion of a large Ammonite, and it's right broken down the middle so we can see the inside of the shell. Just like we saw in the Nautilus, we can see this bit of shell that marks out the division between this chamber and this chamber and this chamber and that chamber. They're not chambers now because they became filled with mud that later turned to stone. But you see they're very simple shell structures, similar to the Nautilus here, but when you get towards the outside part, they become extraordinarily complicated and convoluted and folded. They essentially develop the same structural characteristics as an arch, a Roman arch in a building, or like a buttress on the side of a cathedral. They're a structural feature. That's why engineers love Ammonites, because they invented a lot of really important architectural structures that we only in recent times have duplicated. So they had a thin shell, but it was made stronger by that structure. And we see it externally, and we'll see some close-up pictures here in just a moment. This one's a very simple one where you can see the separations, and they're not too folded and complex, but they're beginning to be. These are called suture lines. So if I started right here and continued along that one line, even though it's all curvy and complicated looking, each of these marks a separate division of what was a gas-filled chamber in life, because they get filled with mud in this case. Sometimes those gas-filled chambers get filled with calcite. This is a really interesting specimen from Morocco. And again, you can see that complicated internal structure of its chambers. If we slice them open, like this one has been sliced open, we can see inside, and sometimes the chambers didn't get filled with mud. They stayed open spaces that became filled with minerals, in this case calcite, beautiful crystals. Great stuff. So how come these Nautiluses survived and the Ammonites didn't? Turns out to be a reproductive situation. Nautilus were survivors because even early on in their history, when they started as straight-shelled creatures and then eventually coiled up to put their center of gravity to a smarter place for maneuverability, they produced very few eggs, but they produced them many times during their life, and they were large eggs. So when they hatched, the young larvae of the Nautilus essentially hatched out as a beginning of a little miniature Nautilus and could go off living as a Nautilus right from that point. Ammonites started out that way, and that's why they were successful like the nautiloids. But during the Mesozoic, as the Mesozoic went on, we see Ammonites changing their reproductive structure. They started to produce huge numbers of eggs at one time. So they grew their entire life first. These are the exact same species of Ammonite. They are heteromorphs. They're not straight-shelled. They're not completely coiled. You see they started out coiled, and then they grew straight, and then they sort of curved around, and then they reach adult stage, and then they'd reproduce. This is the boy, by the way. So he would fertilize the eggs. This is the mama, and she would lay the eggs, and the eggs were very numerous, very tiny. So tiny that when they hatched, they were really the size of like plankton, that live in the very upper parts of the ocean. And when the Cretaceous ended with the meteorite impact in the Yucatan Peninsula, it not only messed up the atmosphere in many ways, it also messed up the ocean, especially the surface of the ocean. Make it simple, it killed off all the plankton. Now, if you kill off all the plankton on the surface of the ocean, and the Ammonite babies are all in the plankton, you just killed off all the Ammonite babies. They only reproduce once. They're gone. They disappeared very quickly at the end of the Cretaceous, along with the dinosaurs and creatures that ate these things. Again, here's your mosasaur chomping on a baculite, straight-shelled Ammonite that I've showed you once before here. And they don't have anything to eat. Big jawed fishes, like the ones we saw eating the trilobites in a video way back. Same problem. They were a big source of food for a lot of creatures. They disappeared. You cut out an important link in the chain of an ecosystem, the whole ecosystem collapses. So at the end of the Cretaceous, we lose about 50% of all kinds of things that ever lived on Earth at that time. That's not the biggest extinction, though. We talked a little bit about the Permian extinction. It'll be in a later video, where we lose about 95% of all the living things on Earth. Even corals had to get reinvented. You gotta love Ammonites. They are just the fascinatingest critters on Earth. they're not alive, but they're still on Earth, and we can still study them. I wish they were still alive, because I would probably keep one in an aquarium at home. They can be trained. Octopus and Ammonites and Nautilus are the most intelligent creatures, or cephalopods on Earth. They are invertebrates, but they have evolved to be almost like, when you look at vertebrates, compare us to a fish, it's comparing an ammonite to other mollusks. It's like, compare a clam to a cephalopod, like comparing us to a guppy and a human being. I mean, we developed this complicated vertebrate eye. Guess who else developed a complicated, essentially vertebrate eye? These guys did.